Systems of linear equations in two variables. A system of equations means that there's more than one equation. The number of equations in the system will be the same as the number of different variables. So a system of two equations will contain two different variables. A system of three equations will contain three different variables, etc. And we want to find values for the variables that will solve all the equations in the system. This video will cover three different methods. The first method is to solve by graphing. For the two equations, graphing each will produce two straight lines. The point at which these two lines intersect is the solution to the system. Done by hand, this is a very inaccurate method, so we'll be using the graphing calculator. In order to graph on the calculator, the equations need to be in slope-intercept form. So let's rearrange each of these. The first one is 3x minus y equals 2. Slope-intercept form has the y by itself. So we need to subtract 3x, negative y equals negative 3x plus 2, and then divide everything by negative 1. Y equals positive 3x minus 2. Then the other equation is x plus 2y equals 10. I want to get the y by itself. Subtract x. 2y equals negative x plus 10. Remember that there's an invisible 1 in front of that x. Now divide everything by 2. Y equals negative 1/2 x plus 5. Now these two equations are ready to go into the graphing calculator. So to start, to enter the equations into the graphing calculator for them to be graphed, you need to push the y equals button. And then when you push the y equals button, you can enter your equations. When you need to enter an x, you use this button that has x, t, theta, n. And so we put in 3x minus 2, and then we go down to y2 and we put in negative 1/2 x plus 5. The negative is this little minus at the bottom of the calculator. The minus on the side is for subtraction, but the little minus at the bottom is for negative numbers. Many times an error results because we get those two mixed up. So the little negative at the bottom is for negative numbers, and to do a fraction, to do 1/2, you use the divide button. So it's negative 1 divided by 2x plus 5. Then we want to graph. And we want to make sure we have our standard window. If ever you need a different window, I will tell you about that. And so the button at the very top says zoom. And then we're going to choose the 6th option, which is standard, so zoom 6. If you are using a phone app, you might just need to push graph. Now we have our two lines. And what we're trying to find is where the two lines cross each other. If you're using the app on an iPhone, all you have to do at this point is touch right where the two lines intersect. And if you touch the right place, it will turn red, and then it will give you the intersection and you're finished. But if you have the actual calculator or the Android app, we have to tell the calculator to find that spot through the menu. And so what we're going to push next is the second button and then this trace button at the top. Second trace. And the menu that comes up is the menu for different things you want to do with the graphs. We want to figure out where they cross each other, so we're going to choose number 5, which is intersect. So second trace, intersect. And it's asking us what's the first curve. All you have to do here is move the cursor close to where the lines intersect. You move with the left and right arrow keys. You move the cursor close to where they intersect, and then you hit enter 3 times. It will say first curve, you hit enter. It will say second curve, you hit enter. Then it will say guess, and you hit enter again. So just hit enter 3 times, and then it gives you the intersection. Sorry, that's a little bit blurry. But it tells us that x is 2 and y is 4. So the solution to those two equations together is 2, 4. If we replaced the x in both equations with the 2, the y in both equations with the 4, both equations would come out true. Now, if you graph and the lines are parallel, then they never intersect, and so there would be no solution. The second method we're going to look at in this video is solve by substitution. When you're solving for substitution, the first step is to get one variable by itself. We already have that in the second equation. The y is by itself. So we will substitute 2x plus 7 in for y in the other equation. So where I see a y in the top equation, I'm going to replace it with 2x plus 7. Now we have 2x minus 3 times 2x plus 7 equals negative 13. And now I can solve this equation, distribute the negative 3. 2x minus 6x minus 21 equals negative 13. Combine like terms, 2x minus 6x is negative 4x minus 21 equals negative 13. Add 21. Negative 4x equals 8. And divide. X equals, that should be a negative 4. X equals negative 2. Now we have x, we also need y. So we're going to plug the negative 2 back in for x into either of the two original equations. The easiest one to plug into is the one that has y by itself. So I'm going to put the negative 2 in for x in the second equation. Y equals 2 times negative 2 plus 7, which would be negative 4 plus 7, which is 3. So my solution is negative 2, 3. If we had graphed those two lines, they would have crossed at negative 2, 3. Another substitution problem. The first step is to get one variable by itself. I can choose any of the 4 variables I want, but if you have a variable with no number in front of it, that's always the one to choose. That's the easiest. Otherwise, you'll end up with a lot of fractions. So since the x in the top equation has no number in front, I'm going to get that x by itself. So I need to subtract 2y. And I have x equals negative 2y plus 4. Now I'll substitute the negative 2y plus 4 in for x in the other equation. Because it says x equals, I have to plug that in for x. So 2 times negative 2y plus 4 plus 4y equals negative 8. Distribute. Negative 4y plus 8 plus 4y equals negative 8. My 4y's will cancel. And what I'm left with is 8 equals negative 8, which is nonsense. So the variable is gone, and the result is false. In general, if you get something weird and it's false, 8 does not equal negative 8, then there is no solution. So if you get something weird and it's false, The answer is no solution. The third method is to solve by addition. Sometimes this is called elimination. Sometimes this is called linear combinations. So if I want to solve by addition, we need to add the two equations together. We want either the x's or the y's to cancel each other out when we add the equations. So you just have to choose. Do I want to get rid of the x's or do I want to get rid of the y's? Suppose I choose the x's for this example. I need the numbers in front of the x's, the coefficients, to be the same, except one needs to be positive and one needs to be negative. So using the same kind of thinking we use to get a common denominator, I can turn both of those coefficients into sixes if I multiply the top by 2 and the bottom by 3. 3 and 2 both go into 6. That would be sort of like thinking like a common denominator. So to turn the 3 on top into a 6, I multiply by 2. To turn the 2 on the bottom into a 6, I multiply by 3. But I have to multiply everything on top by 2, all the terms. And I need to multiply all the terms on the bottom by 3. So now my top equation becomes 6x minus 2y equals 14. The bottom equation becomes, oh, and I should have done a negative 3 on the bottom because I need one 6 to be positive and one 6 to be negative. The bottom equation becomes negative 6x minus 9y equals negative 3. And now we add, and so because I have a positive 6x and a negative 6x, those are going to cancel. Negative 2y and negative 9y make negative 11y equals 14 minus 3 is 11. Now divide to get the y by itself, and I have y equals negative 1. So I have y, I have to also have x. I can plug the negative 1 in for y into either equation, either the top or the bottom. I'm going to put the negative 1 in for y in the top equation. So then I'll have 3x minus a negative 1 equals 7. 3x plus 1 equals 7. Subtract 1. 3x equals 6. And divide. X equals 2. So my solution is 2, negative 1. You can always check your answers by plugging the first number in for x in both equations, the second number in for y in both equations, and make sure both equations come out to be true. Another solve by addition. Once again, I think I'm going to choose to get rid of the x's. You can do the y's if you want. I could multiply the x on top by negative 4 so that I have a negative 8 to cancel with my positive 8 on the bottom. And I have to multiply everything by negative 4. So my top equation becomes negative 8x plus 32y equals negative 40. And the bottom can just stay the same. My x's cancel, but so do my y's. So I just have a 0 on the left side. And on the right side, negative 40 plus 40 is also 0. So I ended up with something weird again. But this time it's true. 0 does equal 0. So if you have something that's weird and true, the answer is infinite solutions. Basically what that means is it's the same line. If you were to graph both of those, the line would be right on top of itself. So all points solve both of those.